When you ask ChatGPT a question, it does not open a tiny library in its head. Unless a search tool is connected, it is not checking the internet. It is not remembering a sentence from a secret database and handing it back to you. It is doing something stranger. It is predicting the next token. A token can be a word, part of a word, a number, a space, or punctuation. The model looks at the tokens before it, calculates what is likely to come next, chooses one, then repeats the process. Again and again, until a full answer appears. That sounds simple. Almost insulting. Like calling a novelist just a person pressing keys. But here is the uncomfortable part. This next token machine can explain code, pass exams, summarize legal documents, write poetry, debug software, and sometimes outperform people who are absolutely convinced they are thinking. So the real question is not, does ChatGPT think like us? It does not. The real question is, if it is not thinking like us, why does it work so well? Start with the basic illusion. You type, "Why is the sky blue?" ChatGPT replies with a clean explanation about sunlight, atmosphere, and scattering. It feels like it knew the answer. But internally, the model is not pulling out a fact card labeled sky blue. It is generating a sequence that best fits the question, the conversation, and the patterns it learned during training. At every step, it is asking, given everything so far, what should come next? That is why the phrase, just autocomplete, became popular. Your phone predicts the next word. ChatGPT predicts the next token. Same basic direction. But the comparison breaks down fast. Phone autocomplete has a tiny window and shallow patterns. A large language model has absorbed statistical structure from enormous amounts of text. It has seen explanations, arguments, mistakes, corrections, proofs, recipes, jokes, source code, and human disagreement. It does not store them as a searchable library. It compresses patterns into billions or trillions of numerical relationships. The breakthrough that made this scale useful was the transformer. Before transformers, many language systems processed sequences more step by step. Transformers use attention. Attention lets each token weigh the importance of other tokens in the context. In a sentence like, "The doctor told the patient that she should rest," attention helps the model track which words relate to which ideas. In code, it can connect a variable to where it was defined. In an argument, it can connect a conclusion to a premise far earlier in the prompt. This is not consciousness, but it is also not a dumb list of word frequencies. Attention gives the system a way to build context-sensitive representations. Scale gives it room to encode more patterns. And training forces it to become very good at continuing text in ways that reflect the structure of the world as described in language. That last phrase matters. As described in language. Language is not reality. But language contains maps of reality. Scientific explanations. Legal reasoning. Mathematical steps. Human preferences. Social scripts. If you train a model to predict language at massive scale, it begins to pick up some of the structure behind the language. That is why GPT-3 shocked people. It could be given a few examples of a task inside the prompt, and then continue in the pattern. Translation. Question answering. Simple arithmetic. Style transfer. It was not being retrained for each task. The task was being described in text, and the model adapted through context. This is where just prediction starts to feel too small. A chess player also predicts. A doctor predicts. A scientist predicts. Prediction alone is not trivial. The question is what kind of internal machinery supports the prediction, and whether the prediction is grounded, reliable, and checked against reality. ChatGPT adds another layer, post-training. A raw language model is not naturally a helpful assistant. If you ask it a question, it might continue your prompt, imitate a forum thread, write nonsense, or produce something unsafe. To turn a base model into something like ChatGPT, developers use instruction tuning and human feedback. Humans write examples of good answers. Humans rank outputs. The model is trained toward responses people prefer: helpful, polite, direct, less toxic, more likely to follow instructions. This is why ChatGPT does not just complete your sentence. It behaves like it is trying to help. But that helpfulness creates a new danger. A system trained to be helpful may answer even when it should hesitate. A system trained on plausible language may produce plausible falsehoods. A system rewarded in exams and benchmarks may learn that guessing is often better than saying, "I do not know." That is what hallucination really is, not a ghost in the machine, not a mystical failure. A hallucination is fluent language that sounds grounded but is wrong, unsupported, or invented. Ask for a real citation, and it may generate a citation-shaped object. Ask for a biography detail, and it may produce a date-shaped answer. Ask for a legal rule, and it may generate something that sounds like law. The scary part is not that the sentence is weird. The scary part is that the sentence is smooth. Humans are trained to trust fluency. If someone explains something clearly, confidently, and with the right vocabulary, we assume there is understanding behind the words. ChatGPT exploits that instinct accidentally. It speaks in the costume of knowledge. This is where the expert fight begins. One side says these systems are stochastic parrots, powerful pattern machines that manipulate linguistic form without grounded meaning. They warn about bias, opacity, environmental costs, and the danger of confusing fluent output with understanding. The other side points to the capabilities. These models solve unfamiliar problems, write working code, reason through tasks, and show behaviors their creators did not explicitly program. Maybe next token prediction, scaled far enough, becomes a surprisingly general learning signal. The honest answer is that both sides see something real. ChatGPT is not a human mind. It has no childhood, no body, no private experience, no biological needs, no direct contact with the world unless tools connect it to one. But it is also not a toy autocomplete bar. It is a trained statistical system that learned deep regularities from human civilization's text, then was shaped to converse with us. That makes it useful. And dangerous. The danger is not that ChatGPT is secretly conscious. The danger is that we keep treating fluent language as proof of understanding. We paste in medical symptoms, legal questions, financial choices, emotional problems, business decisions, and the machine responds in the voice of certainty, even when certainty is not justified. Future systems may reduce this problem. They may search the web, cite sources, use calculators, call databases, run code, check their own work, and express uncertainty better. But notice what changes. The model becomes part of a larger system. The prediction engine gets tools, memory, verifiers, and guardrails. The trust question does not disappear. It moves. So the next time ChatGPT gives you a perfect answer, do not ask, "Is it thinking?" Ask a better question. What process produced this answer? What evidence supports it? And what would prove it wrong? Because ChatGPT is not a brain behind a screen. It is a prediction machine wearing the shape of conversation. And the reason that feels terrifying is not because the machine is becoming human. It is because humans are so easy to convince with words.